Good morning, everyone. Today is our first class for computer-aided engineering. Today's objectives include review the syllabus, the contract between the professor and the students, and then we will review some special policies during COVID-19 pandemic, and then we introduce the analysis of stress. First, we talk about the syllabus. And syllabus is a contract between the professor and the students. And first of all, this course, Computer-Aided Engineering, is required course, which means that if you are a mechanical engineering major or aerospace engineering major, you need to take this course and pass this course. Otherwise, you will not be able to get your degree. The lecture will be given at MDH 2094 from 12:45 to 2 o'clock p.m. Tuesday and Thursday. The tentative office hour is 11 to 12 Monday, Wednesday, Friday. If this time slot does not work for the majority of my students and I would like to change this one, or I can just make individual appointments with my students. Then we talk about the textbook, and we are going to use Advanced Strength and Applied Elasticity 6th edition. The authors are Ugurio and Fenster. It is from the Prentice Hall, the publisher, 2020. And in addition, we are going to use PRE and Creo online documentation because we are going to design something and then we do the analysis. And definitely we will use Abacus. Abacus is FEM tool for us to solve the problem, solve the real life problems numerically. And then we will use University Canvas often, and this is our major platform that we communicate about our course. Then we talk about the prerequisite, and I say 310 mechanics of solids is a prerequisite. And if you have taken this one, or you are taking this one concurrently this semester, and that will be great. However, if you do not have this prerequisite and you need to spend more time to work on this course in order to get a decent grade. So the assumption is that your advisor allows you to take this course if you do not have this prerequisite. The topic prerequisite includes an overview of engineering design processes and stress and deformation due to axial bending, torsion, and shear loads. And then there's also properties of materials and statically indeterminate problems and what is statically indeterminate problems, analysis of plane stress and plane strain, and also you need to know some fundamental computer programming skills. For example, using MATLAB, C++, Fortran, Basic, Java, etc. This course covers analytical and computer-based methods to design and analyze elastic structures. The tentative topics include analysis of stress and strain, stress-strain relations, compatibility, and two-dimensional elasticity, plane stress, plane strain, and failure criteria and static and dynamic loading. Then we talk about fracture mechanics, the introduction to fracture mechanics. After that, we are going to introduce numerical methods and including fundamentals of finite element analysis. Then we talk about analytic methods, And then we introduce the design optimization. Elastic stability, if the time permits, and we are going to cover elastic stability and buckling. Also bending of beams with asymmetric sections and torsion of prismatic bars. Any questions regarding this slide? And then we talk about course objectives. After you finish this course, you should be able to apply failure theories to identify potential failure locations and modes, and use computer tools to design and analyze mechanical systems, perform stress analysis using analytical and computer tools, visualize stress and strain fields, and also optimize design using computer tools. Then we talk about assessment methods. I think all of you guys are very concerned about these assessment methods. And first, we will have 3 take-home exams, and tentative dates include September 21st, October 19th, along with November 21. The take-home exam, final exam, and to be held on December 16th, 2022, and also we will have weekly homework and hand calculations and/or computer assignments given on Fridays and due on upcoming Fridays. Then we will have a bio-inspired arts, adapted engineering exploration and formative assessment project for first 4 to 5 weeks, final project and this final presentation. Then we talk about the evaluation. In this course, and homework takes 20%. We have 3 exams, and each of them will take 10%. And bio-inspired project 15%, project and presentation 20%, and final exam will take 15%. Then we talk about final letter grades. If finally you get your percentage is 93 or bar, you get A. 90 to 92% will get A minus, and so on and so forth. And also I want to mention that the highest grade I can give is A, and I will not give anybody A plus, no matter how excellently you will perform in this course. This is a policy, okay? So don't come to see me after class and ask me to give you A plus. No A plus. The highest grade here is A. And then we talk about some policies. And we will have traditional face-to-face learning lecturing this semester, and lecture attendance is highly recommended. And if you must miss classes, please contact your instructor or teaching assistant by email or inform them of your absence. Notification should be provided at least 1 hour before class, so I can know that the reasons and you are absent. All lectures will be recorded and posted online for future independent study purposes. If you are unable to attend the lectures in person, and you still have access to the recorded videos of lectures online. So this is very important. Students need to complete all exams, homework assignments, along with final projects to get their final grades. Later homework will not be graded without prior instructor permission. Any questions regarding this slide? No question. And this is the syllabus. 8. No makeup exams and homework will be given unless permission by the instructor is given prior to the scheduled exam quiz homework for qualifying absence as determined by the instructor or by university policy. You should know that, okay? Qualifying absence. And students will be able to make up a maximum of 2 missed assignments through completion of alternative exams and or homework within 48 hours of the originally scheduled exam or homework due time. If your course instructor becomes ill and is unable to continue teaching, an alternative instructor will teach the course for as long as necessary, and cheating will be resulted in automatic grade of F for this course. Cooperative learning is encouraged, but you must understand the material and turn in your own work. Um, Copying homework from another student constitutes cheating. You will most likely not perform well in this course unless you do and understand the homework. And homework must be legible and show units for all quantities. And because for mechanical engineers and aerospace engineers and also any engineers, units matter a lot. Homework violating these criteria will not be graded. There are mandatory statements on face masks. And throughout the COVID-19 pandemic, key safeguards like face masks have allowed our university to safely maintain in-person learning. And if public health conditions and local, state, and federal restriction demand it, the university may require that all members of our campus community wear face masks indoors. So therefore, anytime a university level face mask requirement is in effect, and face masks will be required in this class. So this expectation will apply to all students and instructors unless a medical condition warrants exemption from the face mask requirements. And be very, very careful. All right? Uh, when a university-wide face mask requirement is in fact, the following will apply. And students who attempt to enter a classroom without wearing masks will be asked by the instructor to put on their masks prior to entry. So the instructor in our class, in this class, I have the absolute authority to ask you to wear your mask before you come in um, the classroom. And students who remove their masks during a class session will be asked by the instructor to resume wearing their masks. And students and instructors may remove their masks briefly to take a sip of water. Okay, so if you need water, but should replace masks immediately. So the consumption of food will not be permitted because it take a longer time, and you need longer time to um, not wear your mask. This is not allowed. And students who do not comply with expectation that they wear a mask in accordance with university-wide face mask requirement may be subject to disciplinary actions and per the rules, regulations, and policies of our university, including but not limited to those outlined in the student handbook. Non-compliance with this policy may result in disciplinary action up to the and include any of the following: dismissal from the course, removal from campus housing, and dismissal from the university. To immediately protect the health and well-being of all students, instructors, and staff, instructors reserve the right to cancel or terminate any class session at which any student fails to comply with university-wide face mask requirement. So you should know that. When a university-wide face mask is not in effect, and students and instructors may choose to wear a face mask or not, as they prefer for their own individual comfort level. Do you make sense? So ADA accommodation for face mask requirements. So our university is committed to maintaining an inclusive and accessible environment. Individuals who are unable to wear a face mask due to medical reasons should contact the Office of Disability Services for student if you are a student, um, or human resources for the instructors to initiate the accommodation process identified in the university's ADA policy. Inquiries or concerns may also be directed to the Office of Institutional Equity and Diversity. A notification to instructors of university-approved ADA accommodations should be made in writing prior to the first class session in any term, or as soon thereafter as possible. Attendance policy. Um, the health and well-being of this university's students, staff, and faculty are critical concerns, and accordingly, the following university policy statements on in-person class attendance are designed to preserve and advance the collective health and well-being of our institutional constituencies. And students who exhibit any potential COVID-19 symptoms, those that cannot be attributed to some other medical condition the students are known to have, such as allergies, asthmas, etc., and shall absent themselves from any in-person class attendance or in-person participation in any class-related activity until they have been evaluated by a qualified medical official. And students should contact the University Student Health Center for immediate assistance. And students, and whether exhibiting any of potential COVID-19 symptoms or not, and regardless of how they feel, and who are under either a isolation or quarantine directive issued by a qualified health official must absent themselves from all in-person course activities per the stipulations of the isolation or quarantine directive. Any questions regarding this paragraph? Students are responsible for notifying their instructor of absence as far in advance as possible. And when advance notification is not possible, students are responsible for notifying each instructor as soon after absence as possible. And consistent with university attendance policy, students also are responsible for all materials covered in class and must work with the instructor to complete any required work. In situations where students must be absent for an extended period of time and due to COVID-19 isolation or quarantine, they also must work with the instructor to determine the best way to maintain progress in this course as they are able based on their health situation. So you need to be very, very careful. Consistent with the university attendance policy, students may be asked to provide medical documentation when a medical condition impacts a student's ability to attend and or participate in class for extended period of time. As a temporary attendant amendment to the university's current university attendance policy, all absence due to illness or isolation or quarantine directive issued by a qualified health official or due to advanced reaction to a COVID-19 vaccine shall be considered authorized absences. Did that make sense? So this is a long policy, and I mentioned this, and I want you guys to take a look after class. On Student Success Center and syllabus statement. So this is required by the university for all these syllabi. And in recognition that people learn in a variety of ways and that learning is influenced by multiple factors. For example, prior experience, student skills, or learning disability. Resources to support student success are available on campus. The Student Success Center, a one-stop shop which assists students with academic and career-related services, is located in Suite 331 in Student Center and in Suite 114 of Student of Nursing School of Nursing building, and students who think they might benefit from these resources can find out more about this. And course level support, e.g. faculty member, departmental resources, etc., by asking their course instructor. University level support, for example, tutoring services, university writing services, disability services, academic coaching, career services, and or facets of curriculum planning. And by visiting the Students Success Center or by going to universities, this is a link. And disability service academic accommodations. Students with documented disability and who wish to request academic accommodations are encouraged to contact disability services to discuss accommodation requirements and eligible requirements. And please contact disabled services located within the Student Success Center at the university and to schedule appointment. Confidentiality will be observed, and in all inquiries will be observed. Once approved, information about academic accommodations will be shared with course instructors via email from a disability service and viewed within a banner via the instructor's course roster. And then we talk about university rating and service. Rating service, and we encourage you to take advantage of university rating service in Student Success Center and getting feedback, benefits, raters at all skill levels, and trained rating consultants we can help with rating projects, multimedia projects, and oral presentations. And University Rating Services offers one-on-one consultation that address everything from brainstorming and developing ideas and to crafting strong sentences and documenting sources. For more information, call the number and visit the University of Service Center website. And students in personnel or academic distress and or who may be specifically experiencing challenges such as securing food or difficult navigating campus resources and who believe this may affect their performance in the course are encouraged to contact the Dean of Student Office for support. And furthermore, please notify the instructor if you are comfortable in doing so, as this will enable them to assist you with finding the resources you may need, assisting you with find the resources you may need. Now, we want to talk about, we have talked about syllabus and policies, several policies for the course and also several policies about this is student learning support, and also we talk about several policies about these COVID-19 pandemic related policies. I hope you have a better understanding of all these policies and don't violate any policies there. Any questions up to now? Any questions to have about our syllabus and policies and up to now? So if you do not have any questions, then we move on to talk about our technical topics. First is the stress, and I so I think you have already known the stress, right? So in high school maybe, and you have learned the stress and what is we know the force and we know the area, and how can we calculate the stress? Um, the force divided by the area uh, at which the force is applied, and you will get the stress. Um, Now it does not hurt if I refresh memory, and because so I'm going to teach you the stress, the concept in more the depths, in more deeper. It's much deeper. Okay, and so here, um, suppose here is the domain, and this here is the domain, and we have the multiple externally applied loads here, externally applied forces here. And then we have a cross-sectional area, and this is which is denoted by AA. And for a generic point Q here, okay? And so we just cut off. This is a cross-sectional area, and we just cut off, and we just isolate. Um, uh, we just for visualization, we just remove the red portion, and we have only have the left portion, and then we artificially establish the x y z coordinate system here. So here is the origin, and here is a q here. Okay, so so this is force. Okay, so we have a force. So this is internal force, and for this problem domain. But so this internal force, for this is the left part, it will be external force. Um, so you can see this is F here, and to this force. Suppose here is a very small, this tiny area, and on this tiny area there is a delta F, this force here, and area is delta A, and then we just take out this tiny area here, okay, and we have force, we have this force has three components. One is in x coordinate, and second one is y coordinate, and third one is in z coordinate. So here is so this is the area is delta A. So here, this is the infinitesimally small cube, and this is x, y, z. And for this cube has six faces, and for each cube, we have stress components here. And for example, on this is the red face, and we have the sigma x here, and we know the normal stress, and we denote normal stress using sigma, and we denote the shear stress using this tau. So this is sigma tau xx equals sigma x, and also we have tau xy and tau yz. On each of these six faces, we have three stress components. And you need to know that um, for convenience, we use the tau, or we use the sigma for all stress components. But you should know that if these two subscripts are the same, it means that this guy is normal stress. If these two subscripts are different, this means that this is the shear stress. The shear stress means that, and this is the direction of this stress is parallel to the surface at which it is applied. Questions regarding this slide? No question, and we move on to the next slide. So here, right? And so here is uh, for convenience, I put this infinitesimally small cube here, and here, and I have sigma x, and this is tau xy, and tau xy equals tau yx. This is a 2D. I use a 2D here, and for this is x and y, and I have sigma x, and here I do not have the stress in the z direction, and so that's the reason I can just simplify this one as a 2D x y. So here is a normal stress, here is a shear stress, normal stress, shear stress, normal stress, shear stress, normal stress, and shear stress. And for this one, right, for this one only has shear stress. Normal stress equals 0. Any questions so far? So this is called element in pure shear, no normal stress. Any questions so far? Okay, look at it here. So this one, uh, so this is x, y, z. And also, in addition to these forces dx, dy, dz, and we also have three moments. This is x, okay, so this is x and t, and so this is, if this moment's direction is parallel to x, we call this a t, the twisting moment is also a moment. And this is my is about this y-axis, and this mz is about z-axis. Any questions so far? And so this is the p is a force, normal force, and the vy is the shear force, and vz is the shear force. Any questions so far? No question? And then we talk about um, variation of the stress within a body. Okay, so this is the um, a kind of messy, but mathematically it is well written. So we have this x, y, z coordinate system. We have an infinitesimally small cube, and on each of these faces, and what you can see here, okay, this is a q prime. This is a q. This is a q, and q prime. And this guy's stress state is sigma xx, sigma yy, and sigma zz. And please note that, and here all the shear stress and normal stress, I use the sigma to denote them. However, as I said, we have two subscripts. If these two subscripts are different, it means that this guy is shear stress. If these two subscripts are the same, that means this guy is a normal stress, and you need to know this convention very, very clearly. Keep this convention in mind. Okay, and then on each of these faces, and we just write this stress state. And on left side, okay, on left side, this is on left side, and we have sigma x, sigma xy, and sigma xz. On back face, and we have sigma z and sigma zx and the sigma zy. On bottom here, we have sigma y and sigma yx and sigma yz. And before I teach you and why this is sigma xz equals sigma zx, and sigma xy equals sigma yx, or sigma yz equals sigma zy. I want you guys to differentiate all these components very, very clearly, okay? Because so this is the subscripts. They have their own significance. I need to tell you. And so, for example, sigma zx, what is the z stands for, and what is x stands for. And I need to tell you, keep in mind and pay attention to what I say. The first subscript denotes, okay, the first subscript denotes the normal of this face that you are talking about. And so x denotes the direction of the shear stress. And for example, sigma zx, right, this is a back face, and back face, back face, this guy's normal is z direction. You understand? Sigma zx. So sigma, so this is a back face. Let's see, sigma back face, sigma z and sigma zx, and this is sigma zy. So because the back face and this guy's normal face is a z in z direction. Normal direction is a z. X is this guy is along the x direction. Alright, this x direction. See the x direction in this x direction. So let me recap what I said. The first subscript stands for the normal direction of the face and you are talking about. The second subscript stands for the direction of the stress. For example, this is a sigma zx is here. It's on the biker face and it is pointing in the x direction. And some students might ask, Dorma, how do you know this arrow should go in the z direction, negative z direction, x direction, instead of this positive x direction? I need to tell you guys, and for this photo, and all the directions, and they are in the positive direction. And what is the positive direction and what is the negative direction? I'm going to talk about this one later. Okay, so this is currently, and you just keep in mind all these stress components, they are written in positive direction, in their positive direction. Then this is left, back, and bottom. Why they have these kind of components? Because left, back, and bottom, these three faces are near this origin. Right? And however, right, front, and top, and they will we will treat it this one as this is a variation. For example, the right face. Right face is equal sigma xx, right? Sigma xx plus something, and plus because this is the length of the size in x direction is dx. So sigma xx is a function of x. So this is on this right face, sigma the normal stress. Okay, so this is sigma xx plus I just draw a circle there. So it equals sigma xx plus the derivative of sigma xx with respect to x because in x direction, then multiplied by the increment of this x. And same thing for these, and same thing for these. Questions so far? One more time. For right, front, and top, and because there is a distance between this point and this origin, and for each of these stress components, and we will have an extra term. This extra term, and we use the calculus, knowledge of the calculus to get. Do you understand? Okay. Now, once you understand all this, because we know this infinitesimally small cube is in the state of equilibrium, and then we know that all the forces so this guy is in force balance and also in moment balance. In force balance means that all the resultant forces in x direction, y direction, and z direction are equal to 0. A moment balance means that the moment about x-axis, y-axis, and z-axis are equal to 0. And please note that force and stress, they are related, but they are totally different. And how these two guys are related, and the area, okay, the area where the force is applied, and this area relates the force and the corresponding the stress. And you need to be very, very clear about this. We have force balance, we have moment balance. We do not have stress balance. Be very, very careful. Okay, so based on my teaching experience, many students they made a mistake and think there is a stress balance equation. No stress balance equation. And then we talk about this is a 2D. Okay, so this is stress. This is a this is stress. This is stress. Stress. This is a transformation here. So this is x, and so this is y, and so this is x prime. This is y prime. If we rotate, this is x y coordinates to get x prime y prime, and which forms angle with x and y and the theta here. And so here you can get, this is the element in plane stress here. Okay, so here this is a wedge, and we have x and y, and so this is a theta, and also this guy is in the state of equilibrium also. Here is a tau xy, sigma y, and sigma x. This is a tau xy. Okay, so this tau xy, and this also, this one should be tau yx, and then because so these two guys are the same, and we just use the tau xy here. So here is a stress concentration, stress. The transformation. If we know the stress state, and if we rotate this x, y, and to x prime and y prime, how can we get this new stress state? So this is a topic we are going to cover later.